Howdy everyone, my name is Suman Kumari. Today I am presenting this video as part of our data visualization classwork. I will discuss the paper named In-Store Shopping Decisions Support through Augmented Reality and Immersive Visualization, whose main author is Bingzi Zhu, along with multiple co-authors. This paper was presented in 2022 IEEE Visualization Conference. Let's move to the motivation and goal behind this paper. So, this paper is motivated from the shopping experience done online and offline both. In online shopping, as we all know that for buying a product, we see multiple options, and also we could check the product details very easily and their customer reviews, all from the home very comfortably. But still, the online experience can never overcome the satisfaction and the gratification which we get through the in store shopping and the kind of hands on experience. So, when we do a in-store shopping, that also comes with multiple challenges. Like sometimes the stocks are not available, or or the things like we cannot have that much feature related information when we are buying in store, and it's also not feasible to get the other customer reviews and ratings. So to ease this process, this paper has came up with the idea of augmented reality shopping which if we see in the existing world there is already this method, but it can only provide the information related to one product at a time. So this might not be very useful when there are so many similar products and there are so many alternatives for the product which we want to buy. So the goal of this paper is to present the augmented reality shopping with a web-based prototype to visually communicate detail of the products and their informations, and also incorporate the comparative data visualization into augmented reality so that the user can make the decision um, at a point of time or at the place where they are shopping without any intervention or without any problem. So first, I'll go with the example and show you how this idea works, and then I'll go over and deep into the technical details. So let's assume that you have joined a gym and you are on a strict diet, and your dietitian has told you to like consume a certain amount of protein and things on the daily basis. So you go to a grocery store and there you see a lot of protein bars on the rack. So having lot of options, now you start checking all the nutrients value in contained in each protein bars. So after reading lot of nutrient facts about all the protein bars, you are confused. Now you don't know which one to buy. Even like multiple of them are meeting your criteria and some of them are not. But it's very difficult to read each one of them and then identifying which one you should be buying. So there comes this web-based prototype, which is developed as part of this paper. So let's see this small clip and understand that. So when you keep the camera in front of the rack, it gives you a drop-down menu with the multiple options. Like you can check the protein options you want, and then you can check the calorie options you want, and then you can also give the ratings or select the ratings with which you want to filter your options, and you get four options as per your filter. After this, among these four, which one you should select, that it will automatically show the GLIP graph representation with the multivariant feature of these protein bars. So according to your variant, you can select like in which you are having the maximum protein. So you can go with that one. So you have selected the one. But what about the other three? Like if you want to compare the other three also, then you can bookmark them and you can go to the comparison mode. So with the comparison mode, you get the compare glyphs, which is like a radar graph. And there also you have options of selecting the multiple variant there, like multiple vitamins here we are selecting and seeing the comparison graph. So we could evidently see here which protein bar is at the top list. So after getting that, like before buying, you could see the previous user experience and the reviews and the ratings related to that one, and then you can make your decision. So this is quite handy while making a shopping. So now we have understood how it is going to work. Let's deep dive into the technical methods behind this. So this is the architecture of the augmented reality shopping prototype, where we have talked about the mobile camera and the camera frame, which we put in front of the product which we want to buy. Then internally comes the first thing, product detection, and the second thing is the user interaction. So as part of product detection, it identifies the product ID and position, which goes to a database query. As based on the database, it retrieves the online information about that product and then feed to the user interaction. And as part of user interaction, as we saw, we have option of filtering, we have option of comparison, and then we can have the real time recommendation, and we can finally make our decision of buying. So let's deep dive into these two methods in details. So first step is product detection module. As part of this, we identify the product by looking into a camera. So the object detection happens and we detect the product ID. Second, through the marker detection, it identifies the position and orientation of the physical product for displaying overlaid visualization glyphs so that the glyph can be presented for the filtered products and that will be oriented aligned with the product itself. And second is the user interaction module, where we saw how the augmented reality shopping utilizes the radar chart to represent multivariant product. And we also saw like how the screening and the filtering can be done and can the multiple glyphs can be seen. And depending on that, we can select our variant and the users can make more detailed comparison via the comparison view also. So moving to the results, as this was already shown as part of the demo, we could see the AR shopping interface and then the filtering options, and then we are having the glyphs for all the products, and then we could do the bookmark of the products, our favorite products, and the comparison mode it can have. Now, let's see the marker detection and the marker object detection, which we talked about for our product detection. So we could see the result with only marker detection and combining that with the object detection. And how the positions and the orientations are detected, it depends on the front view, left view, and the right view. Now, let's talk about the main contribution of this work is it provides a web-based prototype. So it's very handy for the users because they can just use them on their smart devices like phone, tablets, and iPad, and etc. Also, this product information gives us informs of the visualization so that customer can understand it and read it very easily, which is done with the help of the glyphs presentation, and it gives us multiple features and enable intuitive comparison across different products and develop a product detection algorithm that fuses results from object detection and the product marker detection to support better positioning of the glyph in the space. So user can easily could see that which product is filtered as part of their filtration and which is recommended, and glyph will be positioning at that product. So that's a really cool feature of this web prototype. Moving on to next, we could see how this was verified. So this was verified with the help of the 14 participants, and so the case studies were done on that one with the help of their results, and it was done on the scale of 1 to 7 with the technology acceptance model TAM instruments. So we could see that on the scale of 1 to 7, where 1 is strongly disagree and 7 is strongly agreed, for three broad categories, it was surveyed, and we could see in all these three categories, it has topped the class within the scale of 5 to 7. So first, it was checked for the usefulness, and that was red in color from question 1 to 4, and we could see the results are lying between 5 to 6. Next, it was checked for the ease of use for the question 5 to 7, and again it has topped the scale of 7 and 6. So it's very handy for the people. And again, question 8, check the intention of the use, and people are more likely to use this product in future. So what the future work can be like, this web application has been provided currently on only for the smartphones. It has been tested, which can be tested for the tablets and the smart glasses in future. Also, it was developed during the COVID-19 time frame, which that time the real world experience were not considered and experienced, but in the future it should be evaluated on the real world experience and performances. And these are the references I have used. Thank you for listening.